this video, we will be looking at a final factoring method called difference of squares. So before we do that, we're going to start with a warm-up where we use our distributive property, specifically the FOIL, to expand and simplify the following expressions. Now, before we do that, I just want to make a little observation here that each set of brackets, they look almost identical, except they have opposite signs. One bracket has addition, one bracket has subtraction, but otherwise they both have an x and an 8. They both have a 2x and a 5. So let's go ahead and use FOIL to see what happens here. So we're going to take the x and multiply it into our first bracket. So x times x is x squared, and x times negative 8 is negative 8x. Then we'll take the positive 8 and multiply it in. So 8 times x is positive 8x, and 8 times negative 8 is negative 64. When you collect your like terms in the middle here, you will notice that you have a negative 8x and a positive 8x, and they cancel each other out because if you have 8 negatives and 8 positives, that's 0 in total. So we're just left with x squared subtract 64. Now technically you can write 0x in there, but you wouldn't normally see that, so I am gonna just make that x term disappear, and we're left with these two terms of x squared subtract 64. Let's do our next one, and then we'll make a little observation. So this time we're gonna multiply the 2x into the second bracket. So 2x times 2x is 4x squared. And then 2x times positive 5 is 10x, because 2 times 5 is 10. Now we're going to take the negative 5, being careful with the sign, and multiply it in. So negative 5 times 2x is negative 10x, and negative 5 times positive 5 is negative 25. And once again, you will notice that in the middle, the signs or the x terms disappear. And that will always happen if you have the same brackets with opposite signs. So let's look at our observations. The original brackets are the same, except the signs. And that's an observation we made at the start. Now let's look at our expanded form. You will notice each expression is only two terms. Each expression has subtraction, and then the actual two terms are kind of special as well. If you look at 64, if you look at 4 and 25, they are special numbers in that they are perfect squares, meaning if you square root them, you'll get a nice whole number. So for example, the square root of 64 is 8. However, if I tried to square root 60, I would get some sort of decimal, like 7 point something. Also, if we try to square root these terms, so if I square root x squared, that's just x, because when you square root a number, you're asking yourself what times itself gives me that number, and x times x is x squared. And here's the x in our bracket. The square root of 64 is 8, because 8 times 8 is 64, and that's something you can check in your calculator. The square root of 4 is 2. The square root of x squared is always going to be x. The square root of 25 is 5. So when you square root the expanded terms, it matches the terms inside those original brackets. Now remember, when we expand, the opposite of that is factoring. So if I were to go from this form to this form, that is us factoring, and that's exactly what we're going to do now. Now these two-termed expressions that have subtraction and two terms that are square rootable are called difference of squares. Difference because of subtraction, and squares because they are perfect squares, so they are square rootable. Now the way you factor this is very quick. You don't have to think about any magic numbers. The calculator can do the work for you. You just kind of have to remember the process. So our first step is always going to be check for a common factor, because that's always what you have to do. And sometimes if there is a common factor and you forget about it, you might not be able to factor anything. Then you're going to square root both of your terms. Then you're going to put the two terms into two brackets, one that has addition, one that has subtraction, just like we saw in the warm-up. So if I square root x squared, that's x, because x times x is x squared. If I square root 64, just on my calculator, ignoring the negative, that's 8. So my factored expression, I have two brackets. I'm going to start with x, then I'm going to put an 8. One bracket will be addition, one bracket will be subtraction. And it's that quick, but you just have to recognize it. So let's try some more. Now notice, to recognize these, all of these expressions in this first row, for example, they're all two terms. They're all subtraction. And all of these terms are square rootable. If you went to your calculator and you tried to square root a number and you got a decimal, then right away it would not be a difference of squares. So the square root of x squared is always going to be x. You're really just cutting that exponent in half. And the square root of 100 is 10. So to factor it, here are my two brackets. Because x squared was first, both will start with x, and then we'll put the 10. One that's positive, one that's negative. You try C. So pause the video, try it out, then come back. So the square root of x squared is still x. The square root of 25 is 5 because 5 times 5 is 25. So your factored form, each will start with x, each will end with 5, one will be addition, one will be subtraction. So you're just taking those square root answers and putting them into brackets, one with addition, one with subtraction. Now in the next one, all I've done is I've added a coefficient in front of x squared. It really does not change anything. So when I square root 4x squared, the square root of 4 is 2, and the square root of x squared is x. And then the square root of 49 is 7. Now, I'm going to start my bracket with 2x. I'm going to end each bracket with 7. One will be addition, one will be subtraction. And if you're not confident in your work, you can definitely do a quick FOIL to double check. Now, the reason you need this positive and negative sign is so that if you were to FOIL, those middle terms would cancel out like they did in our warm-up. All right, I want you to try E. Pause the video, then come back to check your work. So the square root of 9y squared. Well, the square root of 9 is 3. Square root of y squared is y. Square root of 16 is 4. So for the numbers and the coefficients, you can check that on your calculator. For the variable, you're really just cutting that exponent in half, like I said earlier. So you should have 3y plus the 4, and then 3y minus the 4. All right, for f, you will notice we don't have any numbers. And you might say, well, I have subtraction, but how do I know it's a difference of squares? Well, both of these terms have an even exponent, which means you can square root it. So if I try to square root x squared, we've already seen many times that it's just x, because x times x is x squared. And likewise, if I try to square root y squared, it's just y. So it looks like there aren't any numbers, but remember, technically there is a coefficient of 1 in front of all of them. And then we're just going to do x plus y and x minus y. So one addition, one subtraction bracket. All right, for our next one, 64a squared minus 49b squared. So if I saw this and I didn't know it was a difference of squares lesson or question, I would look at it. I would ask myself if there's a common factor, which there isn't because they don't have a common variable, and 64 and 49, they're not divisible by any same numbers besides 1. So when I see 64 and 49 though, right away, if you have a times table in front of you or you're good with your multiplication table, then you know that those are perfect squares. And actually, let's write down those perfect squares. I'm going to write them right up here. 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. So if you have those numbers just written out in front of you, whenever you see any of those numbers and it's two terms with subtraction, you should be thinking of the difference of squares. So 64 is in that list, 49 is in that list. So let's try to square root here. The square root of 64 is 8, and the square root of a squared is just a. The square root of 49 is 7, and the square root of b squared is just b. And after you have that, it's the same repetitive step. 8a plus 7b, 8a minus 7b. And make sure you start each expression with an equal sign. All right. Next, we're going to add some greatest common factoring in the mix. So when you look at h, you see 25, you see 16. Those are perfect squares. My problem is I have a y there. I can't square root y because y times y is y squared. So what am I going to do to get y? I'm not going to have a nice variable there. But they do both have a y in common, which means we have to do a GCF of y first. So I'm going to divide both terms by y, and I'm going to write it out. And then that just means the y's cancel out, so I'm left with 25x squared. The y's cancel out, so I'm left with 16. Now, if I look in my brackets, now I have a difference of squares. So I'm just going to write this out a little differently. If you like writing this out for yourself, by all means, go ahead. It is very helpful. If you don't need to write it out and you can just do the square root kind of visually and just write it in the answer right away, I'll show you how to do that as well. So first thing, I'm going to write out the y. I'm going to set up my two brackets. And then I'm just going to show my square rooting here. Just a little note for myself. I'm going to square root 25x squared. The square root of 25 is 5x, 5x, and then the square root of 16 is 4 and 4. So add, subtract, and there we are. Now I just showed it like that because I did run out of space a little bit. So I'm going to do that for this line, and then for the last line, I'll do it full showing my work again. Okay, so for I, 8x squared minus 18, I see subtraction, but unfortunately 8 and 18, they're not perfect squares. If I try to square root 18, for example, I get 4.2426. That's not a perfect square. So don't even try to square root that and show me a difference of squares in any way. However, 8 and 18 are both even numbers, and they are actually both divisible by 2. So we have a greatest common factor we have to deal with. So we write out the 2, open up bracket. 8 divided by 2 is 4, and 4 is a nice number because we can square root it. And then 18 divided by 2 is 9, and 9 again is a perfect square. So after I did a greatest common factor, we had a little difference of squares. So here's my GCF, and then I'm just going to set up my two brackets. And now I'm going to square root 4x squared. So the square root of 4x squared is 2x, and then the square root of 9 is 3. Now, if showing your work like this, it can look a little confusing in that if you're re-looking at it in an example like this, you're like, why is there a square root there? Then I recommend you don't do this, and you add this middle step. And I'll do that, like I said, for the last ones. Okay, negative 16x squared plus 25. So first of all, I see 16, I see 25, and I can square root that. But I have a problem here in that the middle is not subtraction, and this is called a difference of squares. So this is not a difference of squares just yet. However, there is another note I've made about greatest common factors, and it's that if your first term is negative, you have to factor out the negative. Now, there's nothing else common here, so we're just going to divide out a negative 1. And all that a negative 1 does is change all of the signs. So the negative 16x squared became positive, and the positive 25 becomes negative. Now we have a difference of squares. So the square root of 16x squared, the square root of 16 is 4, and then the x, and then the square root of 25 is 5. So 4x plus 5, 4x minus 5. All right, 3 more. And they're all going to have a greatest common factor to start, and then a difference of squares. And I will show my work fully and properly here. So we have 16a squared minus 64b squared. Now 16 and 64, they're perfect squares. And this is a little trick question because there is actually a GCF to deal with first. And if you didn't do it, then you wouldn't be factoring fully. And actually 16 and 64 are both divisible by 16. Okay, so why don't you pause the video here, do your greatest common factor, then do your difference of squares, then come back to check your work. Okay, so when I divide both of these by 16, I'm left with a squared subtract 4b squared. And now, I'm going to write my 16. I'm going to open up the brackets, but I'm going to show my work the way I did before. So the square root of a squared is a. So I'll start each bracket with an a. Then the square root of 4b squared is 2b. So I'll make one bracket plus 2b and the other minus 2b. If you got that, great. If you didn't, see where you went wrong. Did you forget to square root something? Did you forget the signs? Did you miss a step? All right, the next one. We have that problem with the negative being the first term, so I know I'm going to have a greatest common factor of negative right away. Now, 2 and 72, they're both even numbers, and they're actually both divisible by 2. So, once again, I want you to pause the video here and follow your steps. You have a nice full example here or above to use as a reference. So try it out, then come back to the video. So here we have to be very careful with our signs. When I divide out the negative 2, I'm left with positive y squared, and then 72 divided by negative 2 is negative 36. And now I have a difference of squares. So the square root of y squared is just y. So that goes at the front. And the square root of 36 is 6. So I'm going to have y plus the 6, and then y minus the 6. And there we have it. All right, last one, x squared y minus 9y. I have a problem with the y's, and they are common to both. So I want you to pause the video, try this example fully on your own, then come back to check your work. So we do have a greatest common factor of y because both terms have that y in common. So they just cancel out, and you're left with x squared subtract 9. And then once again, for the last time, we have a difference of squares because both x squared and 9 are square rootable. We know the square root of x squared is x. We've seen it in almost every example. And the square root of 9 is just 3. All right. So then each bracket will start with an x. One bracket will have plus 3, and the other will have minus 3. And that's your difference of squares. So you will have two terms with subtraction in the middle, and both terms are square rootable. So we square root our terms, we put them in two brackets, one with addition, one with subtraction, and make sure sometimes your expression might have two terms and it doesn't look like a difference of squares just yet, but if you take out a common factor, your leftover bracket might be a difference of squares. And that's it.